Hi, we are going to start this lesson with conditional distributions. We finished the other lesson with marginal distributions, where we're describing the breakdown or the distribution of a certain categorical variable, so the percent that fall into each category. The marginal distribution only considers one variable at a time. The conditional distribution takes into consideration both variables. So for instance, we may want to calculate the distribution of the class variable. So that means that we're calculating the percent that fall into each class, but we're only doing that for individuals that survive. So that would be the conditional distribution of the class variable for individuals that survive, or conditioning it on the survivalship. Okay, so we're going to go ahead and do that. For number one, we want the conditional distribution of the class variable. That means how many fall into each class for passengers who lived. So that's what we're conditioning it on, passengers that lived. So we go back up to our two-way table, which is on the second page. And we only want to deal with the first row. These are the passengers that lived. We want to find the breakdown of each class member. What percentage of first class, second, third, fourth, or crew. So go ahead and do that. So there were 203. So we're always going to divide by 711 because that's the number that lived. And there is 203 from first class that lived. There's 108 from second class. And so that's 16.6%. From third class, there was 178. These are going to add up to 100. And then from crew, there were 212 that lived out of 711. So that's 29.8%. All right, so that's the distribution of class for the people that lived. So that's a conditional distribution. We can also give the conditional distribution of class variable for those who died. And so I can go up to my table again on page 2. And I would just want to deal with this row. I'm limiting my analysis to the passengers that died. So my denominator now is going to be 1490. 122 out of those were from first class, and so forth. So I can fill in that conditional distribution for that. So I have 122 out of 1490, 8.2%. I'll just leave the percentages off. 167 out of 1490, 11.2. And 528 out of 1490 is 35.4. And from the crew, we have 673 divided by 45.2. Oh, sorry, divided by 1490, that's equal to 45.2. All right, and now we have the distribution for both the people that lived as well as the people that died. And so we can compare the two. This is taking into consideration both variables. So we want to see if there's an association between survivalship and what class the passenger came from. So the biggest thing that I notice is the difference between the 8.2% and the 45.2 and maybe this 35.4. These are the individuals that died. Very few of them came from first class, and the majority of them came from either third or crew. And so if I wanted to write a few sentences, that's probably what I would start off with. So among the passengers that died, there was only a small percentage that came from first class, 8.2%. The majority of deaths were from third class passengers or crew members. Okay, so now my description takes into consideration both variables. I'm talking about survivalship and I'm talking about what class they're from. All right, so we're going to finish this off with an example. So here's an example where we have two categorical variables. We have fish consumption and how much individuals eat fish, and then we have whether or not they developed prostate cancer. So yes or no for that, and then never, seldom, small part, moderate, or large for the fish consumption. Again, because we don't have the row or column totals, that's the first thing I'm going to want to do. So I'll go ahead and calculate those. So the first column was 5,806, and the second one is 466. And then for the rows, we have 124, 2621, 2978, and 549. And then for the total number of individuals, that turns out to be 6,272. If I added up the rows or the columns, I should get 6,272 for both. All right, so the first question is, what percent of people in this study developed prostate cancer? So how do I answer that? Well, that's a marginal percentage because it's not talking at all about fish consumption. And so there were 466 individuals that developed prostate cancer out of 6,272. So I take 466 divided by 6,272, and that's 7.43%. Next question, what percent of people in this study have fish consumption described as either moderate or large? Again, this is the marginal because it has nothing to do with prostate cancer, so I'm only considering one of the variables. And moderate would be 2,978, large part would be 549, and I divide that by 6,272. So 2,978 plus 549 divided by the total, and that's equal to 56.2%. Okay, so the next one, of the individuals that didn't get prostate cancer, what percent describe their fish consumption as never or seldom? Okay, so now I'm talking about two of the variables. I mentioned prostate cancer and fish consumption. So this is a conditional one. I'm saying of the individuals that did not get prostate cancer. So I'm limiting myself to this column right here. And so whatever my percentage is, my denominator is going to be 5,806 because that's the total number of people that didn't get prostate cancer. And I'm limiting myself to those people. So never or seldom, that's going to be 110 divided by 5,806. And what is that equal to? That's equal to 1.9%. This one here says, of the individuals that describe their fish consumption as a large part of the diet. So that means I'm limiting my analysis to only those individuals. So if I come back up here, here's the individuals that describe the large part of the diet. So now I'm talking about only this row, and there was a total of 549 in that row. So that's going to be my denominator. And 507 of them had fish as a large, or had, did not develop prostate cancer. And so that's going to be 92.3%. So let's move on to the last question. I want to give the conditional distribution for fish consumption for the individuals that did not get prostate cancer. So what that means is I want the distribution or the percent that fall into each category for fish consumption, but I'm limiting it to the people that did not get prostate cancer. So if I go back up to my row here, that's this, oh, I can't highlight that, but that is this column right here. So I find the percentage of each fish consumption category, and I do that by dividing by 5,806. Okay, so let's go ahead and do that down here. So this is for the no. We have 110 divided by 5,806, so 1.9%. And we have 2,420 divided by 5,806, and that's 41.7%. 2,769 divided by 5,806, that's going to be 47.7%. And we have 507 divided by 5,806, that's going to be 8.7%. So that's the conditional distribution of fish consumption conditioned on the people that did not develop prostate cancer. And then I also want to do that for the individuals that did. And so I would do the same thing. I would do that for this column right here. So 14 divided by 466, 201 divided by 466, and so forth. And so I'll go ahead and fill this in for you. So we have 1.9% for that. Oops. Let's start over. Let's see, so 1.9%. And then over here it would be 3%. And then we calculated 41% for that. And for this one, it'd be 201 divided by 466, which would be 43.1%. Then we have 47.7%. And then we have 209 divided by 466, or 44.8%. And then the large part would be 8.7% and 9.0%. All right, that's it.